In this rotational equilibrium problem, we have a uniform board supports two children with gravitational forces of 320 newtons and 450 newtons respectively. The support is under the center of mass of the board, and the 320 newton child is 1.2 meters from the center. Where should the 450 newton child sit to balance the system? So the way we're going to approach this here is first draw our diagram. We have a 320 newton child. So I'll label that as F1. And that child sits at a distance of 1.2 meters from the fulcrum. And we have a second child that's a little bigger, and that child is 450 newtons. And we don't know where that child sits. That's our unknown. Now, being a larger force, we know that they're going to have a smaller lever arm. There's always that trade-off. So I'm going to draw my fulcrum close to the 450 newton child. I'll label this as my 1.2 meters. And this is my unknown V2. Draw my forces, F1 and F2. Now, the only other thing that we need to write down as a given is our angles. And to get your angle, what you do is you draw a straight line from the fulcrum, that is your point where it rotates about, from the fulcrum to the force, and draw in the direction of force. And we see that this makes a 90-degree angle. So our angle is 90 degrees for the first force, and likewise, our angle is 90 degrees for the second force. We are in equilibrium because the system is balanced. And so our original equation is going to be that the total torque equals 0. And I'm going to write where the torque is Fd sine of theta. Now, every force that is not at the fulcrum, which is right here, every force that is not at the fulcrum produces a torque. So we have two torques, the torque from the first child and the torque from the second child. So I'll write that in there. We have two torques, and they add up to 0. We have to determine which are negative and which are positive torques. So the first child is going to make the seesaw rotate counterclockwise. Counterclockwise is a positive value. And the second child is going to make this seesaw rotate clockwise, which is a negative value. So this first torque is positive, the second torque is negative. Now what we're going to do is replace each of these torques with its force times distance times the sine of the angle. So the first child is 320 newtons. The distance from the fulcrum is 1.2 meters, and the angle is 90 degrees. The second child is minus because it's plus and negative. The second child is 450 newtons. We don't know that distance, and the angle is 90 degrees. And so now we can solve for D2. The distance the second child is away, and we get 0.853. And the units would be meters for a distance. So it is less than the first child, which is what we expected because the child is bigger.